أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the words of Holy Quran. Up till now, my screen hopefully share with you guys, and my voice is also clear at your end. In last, we have discussed about the concept of complex numbers. The concept we have discussed that how a complex number represent and how it looks like. So I'm also sharing my screen with you guys of slide. Uh, the screen is not sharing. So in up till now, if you have any kind of question or query in previous slides, you may ask. I will answer the kind of question. And if you have any kind of question, I will resolve your queries if you have in your mind. Hopefully, all the things have been clear regarding the previous. eh, Okay. Uh, in last we have discussed. I am providing the short review regarding the complex number. That complex number is the entity which is the combination of two real number and the imaginary number, and the combination of real and imaginary become the complex number. So here you can see in last we have discussed the concept of complex number, that is in square root of minus 16, and it is represented square root of minus 16 equal to, it will be called iota into square root of 16, and we got the square root of 16 become 4. So 4 into iota is the result. Last we have discussed these concept as well as in square root of minus 70 that we have discussed. Uh, the third example, as per the sequence, you can see square root of minus 40, square root of minus 48 we have discussed uh, during the session regarding query, voice disturbance. If you have any kind of question or issue, you may ask. I will resolve the query. Hopefully screen is here, voice is clear at your end as well. So in last we have also discussed the concept of square root of minus 48 in complex number, that how it is resolved. So you can see minus square root of 48 would be represent iota square root of 48, that the minus and square root represent iota. So further, if we take the square root of 48 would also be taken as well in the form of square root of 16 into 3. And if we take different combinations of square root of 16 divided into square root of multiply by the square root of 3. So 16, we have the square root, we all know 4, and 3 would be in square root of 3 would be represented in this form. So the conclusion of square root of minus 48 would be represented in the form of 4 iota square root of 3. Hopefully from this to this, how it convert, and no one have the issue in regarding this concept. Further, we all know that the operation of complex number in the form of operation of complex number products or the quotient operation on complex number product or quotient with negative radicals are simplified as a first rewriting as square root of minus a as iota of square root of a for a positive number. Then the properties of real number are applied together with the fact that the square root of the square of iota equal to minus 1. So it is a fact regarding the concept. We can see here it is represented rule for the radicals as well as the multiplication property in the complex number. You can see in particular the rule of square root of c into square root of d. It would be represented square root of in the combination of square root of c and d. The this fact also be represented in this aspect. Sorry for the interruption. We again continue the class. For the square root of minus 4 into square root of minus 9 would be combined in a single square, and it would be minus minus plus, and 9 for 36. And 36 having the square root of 6, we all know. Another aspect that how it be convert in square root of minus 4 into square root of minus 9. So the division of square root would also be represented in this form, that the whole combination of the square root of minus 4 and square root of minus 9 would also be represented in individually. You can see single entity of the square root. So this would be looks in this form: square root of minus 4 into square root of minus 9, and square root of minus 4 would be represented 2 into iota, and square root of minus 9 would be represented in 3 into iota. Further, multiply both 3 into 2 would be 6, and iota into iota would be iota square, and iota square would be minus 1. So another aspect of this would be represented minus 6. You can see the combination. So both the combination of square root of individual values, if we divide each and every square root of minus radicals, like minus square root of 4, minus square root of 9, it is not equal to the whole square root of minus 4 into square root of 9. So both the values of distribution property cannot be fulfilled by individual dividing of square root and the this fulfillment of square root in this single entity. So another aspect of multiplication of single entity of the square root can also be represented in this form. So the whole division individual square root of numerator and denominator of respective of square root of minus 20 and over the square root of 2 would be represented in this form. So this radical, how can we represent? You can see square root of minus 20 would also be represented in iota into square root of 20. Square root of minus 2 would be represented iota into square root of 2. Both the iota in numerator and denominator cancel with each other, and would also be looks like in single square root of or numerator and denominator 20 divided by 2. Both the numbers are divided with each other 2, 20 and 2 and looks like square root of 10. So this further the square root of 10 cannot be each and individually divisible by further the numbers. So it cannot be further divided into further factors of a square root of 10. So the answer is, and over here we can see uh, this question of square root of minus 20 over minus square root of 2 would looks like in square root of 10. Up till now, if you have any kind of question, query or difficulty regarding the question, regarding the session, regarding the question, you may ask, I will answer the kind of question. And in comment section, you also write your question. I will answer your questions. We further this complex type of difficult question in complex numbers. So further, we are discussing square root of minus 8 plus square root of minus 128 divided by 4. Uh, it is also be looks in standard form of complex number, that how can be represented, that minus 8 plus square root of minus 128 divided by 4. So it can also be represented equal to minus 8 plus square root of minus 64 into 2 divided by 4. So 128 can also be right in subfactors of 64 and 2. The repeated of minus sign can also be right in this form. After that, we take the square root of 64, that we know that 8 8s are 64. So it and the minus sign of iota with this factor can also be right 8 of iota square root of 2, which is the further simplification of the square root of minus 128. So we take common in numerator 4 as well as this 4 in numerator and denominator would be cancelled with each other, and in blue form of text of this term of 8 iota into square root of 2 would be represented into 8 into iota. So I also uh, provide the concept here. You can see this of minus square root of 64 and equal to 8 of iota. So coming towards the next step of this sequencing, further the square root of minus 64 would be represented in iota of the 8, and we take common of 4 from numerator, and numerator of 4 and denominator of 4 would cancel with each other, and we got the value of 4 and minus 2 plus 2 iota into square root of 2. So this factor would be represented in this form, and the lowest term of answer of this complex term minus 2 plus 2 iota into 2 would be represented would be looks in this form. So it's a difficult question of complex number. You have, if you have any kind of question, query or difficulty, you may ask. I answer the kind of question. Further, we moving towards the next concept of complex number. The addition and subtraction property in complex number. If we have two numbers of complex a plus b into iota plus c into d iota. So both the numbers of real radicals, here is a and c, are combined with each other. If we are we are having the term of addition in the complex number. So b iota and d iota will also be add in this form. Iota would be take common from this. Same property can be implemented in complex number. Both the real numbers subtract with each other, and both the imaginary number will subtract with each other. And this is how we can deal with the complex number addition and subtraction with each other. Further, the how commutative and associative distribution property would be fulfilled over here. You can see that if we talk about the addition of complex number, both the real number here is 3 and -2. In complex number, we all know that as per the sequence, real write down first and second is the imaginary value, and both the real imaginary would be represented called complex number. So both the complex number in addition form, we can see all two real numbers, of 2 or 3 and -2 would be right in this form in first, plus, and at second level -4 iota plus 6 iota would be represented over here. Iota would be common from these imaginary values. So it where we here we can see that if iota is associated with some kind of a number, it is we called imaginary value, and without the iota represented value is we called the real number. So the real part of this term represented over here, and imaginary part at both the value of complex number right over here. So real plus imaginary become the complex number. Further, at both two numbers of real part, we got 1, and the imaginary value of -4 plus 6 would we have 2 iota. So this is the result of complex number from the addition. We got the value of combination of both the complex number in addition form. Further, coming towards the concept of for the next question, that is further we coming toward the concept of another aspect. So how can we solve this question? So you can I have provided the concept of both these two complex numbers. How can we add these two numbers? So it's an exercise question for you guys, that how can we resolve this complex number? And you can see yourself, if you have any kind of question, query, or difficulty, you may ask. Uh, I will provide this exercise to you. Uh, look in detail and ask if you have the question. Okay, thank you very much. Further, we continue the session. So hopefully you have no kind of question in this exercise exercise task, and you may understand yourself that both the real numbers would be add in this form, and both the imaginary values would be add in this form, and the last result of -6 and -8 iota would be represented in this form. We further comes to the concept of the complex number that is in the subtraction form, that how it would be represented: -4 plus 6 and -3 iota and -7 iota. Both the real number would be arranged with each other with a negative sign, and both the imaginary value would be represented with each other in the negative sign, and both the real and imaginary value subtract with each other, and the last result of -10 plus 10 iota would be represented in this form. Further, this is another exercise question. You may understand yourself. I provided to you guys. If you have any kind of question, query, or difficulty in the previous questions and the current question, you may ask. So I am providing exercise question. You may understand yourself and ask if you have in your if you have any kind of question. Okay, further, hopefully, there is no question in this exercise. So we further moving towards the next concept of complex number and transformation. So it's another exercise of complex number having a and b. If we add both complex numbers z1 with z2, that how would be result, and z1 and z2, what will be the result of both complex number if we multiply with each other. So coming toward the concept of complex numbers, uh, here you can see we have both the complex numbers z1 and z2 in this form. We arrange both real values and imaginary value with each other, add or subtract both real value, imaginary value with each other, and we get the concept of -1 plus 12 iota. Coming towards the next part, that is b, as per the distribution law, iota square equal to -1, in product form, we can see z1 and z2, how it will looks like. So multiplication of complex number, we need to understand here that we have complex number z1, 2 plus 4 iota into -3 plus 8 iota. We have to multiply both the complex numbers with each other, and what will be the result we got. So we need first got the complex number, that is z1, 2 plus 4 iota over here, multiply with -3 plus 2 plus 4 iota multiply with 8 iota. So both the complex number multiply with another one, and it looks like in this step. Hopefully there is no kind of question in your mind that how it would be represented in this form, and this complex number, and that how this complex number would be represented in this form. So multiply with each and every individual complex number. You can see that -3 multiply with 2, and -3 multiply with 4 iota. and we got the value 3, 4, the 6, and for the 12 iota. Irrespective of the negative sign, we have the values of -6 and -12 iota, as well as the 4 plus 2 plus 4 iota into 8 iota. So multiply with 8 to the 16 and 8 4 the 32 iota square as well. Iota multiply with 2 would be in this form of 8 to 16 iota, as well as the iota into iota become iota square. So both the value of real value, okay, you can see that iota square, we know that it is -1. So iota square -1 would be -32 in aspect. So this would become the real value, as well as -6 is the real value. Why they are the real values? Because these have no kind of from iota. Both the value of -6 and 32 arranged with this form, 12 iota and 16 iota would be looks in this form. Take the common of iota from both the value, and we got real plus imaginary. So subtract with each other we got the value of -38 plus 4 iota. It's the last result. So if you have any kind of question, query, or difficulty in this addition of complex number and multiplication of complex number, you may ask. Uh, uh, you can once understand yourself. I'm providing you the exercise of these terms, and that if we have two complex number multiply with each other, that what will be the result of these values. So you may understand yourself and solve yourself right now, and in few minutes I will share the result to solve yourself and verify your result. So I'm taking a short break over here to solve this question and verify your answers. Hopefully you have no kind of question, query, or difficulty in this question. I will provide the result of this question further. Uh, okay, further we comes to the question solution. Over here, you can see we multiply each and every individual value of complex number of first one with the real value, and further the complex number with another imaginary value, and we got the value of both the real 6 and -12 iota, both the imaginary value 8 iota and -9 iota with each other. Arrange both the value of real 6 and plus 12 with each other, and 6 plus 12 become 18. Both the value of imaginary would be subtract with each other, and we got the value of minus iota, and it looks like in this form. So the multiplication of complex number you can see over here, and I think there is no kind of question query in this question. So regarding the multiplication of complex number, we are clear, and we got the exercise question as well. So coming towards the concept of complex number mapping. So we know that the real value is map over here in x-axis, and imaginary value which is relevant or related to the y are arranged over here. So real values are represented of x, imaginary value are represented in place over here. The combination of real plus imaginary, that how it looks like over here. If we map the value of x over the imaginary value of 0 represented in this form, and if we map the value of imaginary, that is 0 comma 1, that is placed over here. If we need to place a complex number which have the real value having imaginary value of 0, map over here like this. And if we have the imaginary value which having x value related to 0, that particular imaginary value would be represented in this form. So these are that how it looks, and how to map the complex number in the abscissa and ordinates in graph. So how it looks, we can see. So the real number over imaginary, that how it be represented over here, you can see we need to add both the real numbers with each other, imaginary value with each other, and in multiplication we need to multiply with complex number 1 to each of one every individual value, and we got the result. As well as the concept of this multiplication we have clear over here. If there is a entity having 0 terms over here, we can see in this form. So this is the distribution property as well as with the multiplication. So this is the repeated slide of mapping of a complex number. If the complex number is placed every individual axes over here, you can see if we need to place a complex number that have the value of imaginary 0 would be mapped over here. If we need to map imaginary value of a complex number, that is the imaginary value over here like this. So it's a repeated slide regarding the concept as well as the addition of a complex number with the distribution property. We have also be clear over here. I will share this slide in your group. We have the two different group of students, so I will share this slide in all two groups as well, uh, or as well as the classroom of Google Classroom. I will share with you guys in real time as well. So this is the basic algebraic properties of multiplication property as well. We can see over here basic algebraic properties of distribution property over here. You can see uh, there is no such things over here. So this is exercise question. I will share with you guys. Leftover, that is the subtraction of complex number as well as the division of complex number. There's a leftover thing that is the division of complex number that will be discussed in upcoming things. Okay. So I'm sharing with you guys that you need to so you need to join